Okay. All right, so just to repeat a little bit of what I said, we have f prime, or the derivative of f. Our goal is to find f, so we are going backwards. We are undoing the derivative, otherwise known as the antiderivative. Okay. And if we remember, our main antiderivative plan is when we're taking the antiderivative of x to the n in terms of x, and that's all that dx means. The antiderivative of x to the n is x to the n plus 1 divided by n plus 1. We do that for every term in the sum or difference, and we add on a generic c. All right, so I like to see everything at one time. Like a Zoomaholic here. Okay. So what do I got? Well, when I take the antiderivative of 3x minus 7 dx, I get 3x squared over 2. Okay, so because x is x to the first power, so you add 1. A regular constant like 7 becomes 7x. And then we have the additional constant. So that's step 1. Here's my antiderivative. Antiderivative practice, that goes back to, actually, we did a lesson. The first lesson on finding antiderivatives was before I got to stay home with COVID. And so there is a video for that. I think it's like March 18th, 19th, kind of in that time frame. If you want to go back, if you need sort of a review on how to do that. Problems on page 370 was that one of the videos, the first day I was out, the first day that week, I guess that would have been Monday of that week, I put this in a video as well. So a couple different videos on there on backward power rule, finding the antiderivative. All right, next part. We have to figure out the c. So I know that f of x is 3x squared over 2 minus 7x plus c. And I know that f of 1 is 2. Okay, so I'm going to do exactly that. I'm going to plug in 1 for x. So 3 times 1 squared over 2 minus 7 times 1 plus c equals 2. The whole purpose of having this second set of information, the second clue in the problem, is figuring out what the c value is. So the c value has to be so that if I put 1 in for the x's, I would end up with a 2 for the y. Okay. So then grab my calculator if I need to, crunch out that arithmetic. 3/2 minus 7 plus c equals 2. You know, decimals that are halves are pretty good, fine to use. Decimals, when we're talking about like a repeating decimal, sometimes the fraction is more accurate and nicer to use. I think in this case we could go either direction. So negative 5.5 plus c equals 2. So c equals 7.5 or 15 over 2. Okay. If we wanted to do it with all fractions. Big part not to forget is answer my question. My question wasn't what's c. My question was tell me everything about f of x. So f of x is 3x squared over 2 minus 7x plus 15/2 or plus 7.5. And that, my friends, would be the final answer. So, two things you have to know how to do. You have to know how to do the antiderivative steps. Okay. On the review from last class, which I have lost. Okay. On the review from last class, that's what the first 3 problems were. They were just practicing antiderivatives. We're going to do fundamental theorem today, which is just more antiderivative stuff. So we'll be practicing antiderivatives here pretty hardcore. The second step, though, is how to use the antiderivative and the given information to then calculate the C. F of 1 equals 2, that means this is the input, this goes in for your x's or whatever your input variable is, this is what it's equal to, so 1 substituted in equals 2, and we figure out 7.5 for C, and then put it all together in an equation. We looked at an application of this. This was when we went from a marginal cost to a cost, and we could do marginal profit to profit. That was the real application of doing this, going from the derivative or rate of change function to the original function and using information about additional information to kind of fully get that final function. And that was what question 6 was on the review. Okay. So for the first chunk of what's on today's, or not today's quiz, what's on your quiz coming up in a couple weeks, the things that are on this sheet from last class would be the first place to make sure you can go. Make sure you can do all these different antiderivatives. Make sure you can do one of these finding C problems. Make sure you can do the finding C kind of application problem using the marginal function. Okay. All right. Questions about that review question? Okay, so that was the first thing we did in class last time. The second thing we did was we talked about this thing called the fundamental theorem of calculus. We talked about how the fundamental theorem of calculus allowed us to calculate actual areas under curves without needing the geometry. So we're going to go ahead and talk about that again. We're going to look at just a couple basic examples to kind of remind ourselves how it works. And then we'll throw a couple little trickier ones into the mix. So I'm going to stop.